Kilns are some of the largest machines ever made. They operate in a hot, dusty, and otherwise hostile environment. They are constantly rotating 24 hours a day for months at a time. This presents a unique problem for measuring their alignment. The kiln shell is a long, substantially cylindrical body, supported in rotation by rollers beneath it, having no fixed endpoints defining its axis of rotation. How then can we determine whether the several sets of rollers along the length of the shell are actually holding it in a straight line? It is the very act of rotation that provides a unique solution to this question. Previous methods have always established alignment by working through the geometry of the support rollers and tires. But measuring their dimensions and positions on machines this large, while they are in motion and with irregularly worn surfaces, present many difficulties which compromise the results. By viewing the shell alone as a body suspended in space without consideration of how it is supported, rotation alone is used to establish the linearity of its axis of rotation. The following animation illustrates this simple concept. With axis only available from the outside, while it is constantly rotating, knowing it is not round, and knowing it has no fixed center or end supports, how can the rotational center be found? During the course of one rotation, through the means of non-contact measurement, all positions of the shell are measured. Knowing all shell positions from the maximum to the minimum, the statistical average shell position is calculated. This is not just halfway between the minimum and maximum, but a true statistical average of all positions measured. Similarly, the statistical average shell position is measured in two other locations. From basic geometry, only one circle can pass through 3 points. When the circle is formed using the 3 average shell positions, its center defines the center of rotation of the shell itself. With the presence of planetary motion, the center of rotation will be different from the center of the shell. Kiln shells almost always have a measurable amount of planetary motion along their length, since they are never perfectly straight. The procedure is repeated at all points of interest. Centers are identified by the coordinates within a known reference grid. By selecting an optimum reference line, the deviations in position of the centers of rotation are quantified. Of particular interest is that this entire procedure is accomplished without expecting the shell to be round, while allowing for planetary motion, without knowing how the shell is supported, without having measured any diameters of shell, rollers, or tires, without physical contact to the moving shell. The state of alignment based on the centers of rotation has now been established.